where we left off on Tuesday. I didn't want to jump too far into this topic because there's a lot to cover. It's dry in some points, but we'll try to make it light at times as well. We were talking about web security or web applications, and one of the major takeaways I want you to leave this topic with is the understanding that yes, at the end of the day, it is just software and networking, like really any other type of application. But there's some interesting aspects of web security that necessitate just further, closer inspection. And then that's why we have this as a separate topic and is conventionally listed as a separate topic from just software vulnerabilities in general. I do want to make sure we all have a sufficient, very high-level background in what we're talking about here. And I note that I list some very pleasant historical figures, and you may not know who they are. So Sir Tim Berners-Lee, sort of the inventor of sort of the fundamental technology we're talking about today. Another person I list here, Mark Andreessen from Iowa. And who says nothing good has ever come out of Cedar Rapids? At least there's one thing that indirectly came out of Cedar Rapids. Does anyone know co-creator of the first widely used web browser? Does anyone know what is the name of the first widely used web browser?
Is it Mosaic?
It is Mosaic, that is correct. And he is creator of Mosaic with other people at University of Illinois, National Center for Supercomputing Applications. Mosaic became...
Netscape?
That's correct. Does anyone here actually use Netscape? Okay, Netscape became Firefox, right? It's the same piece of software. And a lot of still the same exact cruft existing despite some attempts to kind of rewrite major parts of that code base here. So Firefox that many of you use today, from Cedar Rapids to Firefox, who would have thought it? When we talk about HTTP, when we talk about web applications, it is an application layer protocol that is driving all of this. And we are aware of this, but sometimes we don't really think about what is actually happening here. It is a text format protocol, and it is just an attempt to have a relatively high-level interface language between our clients and between our servers. I had that kind of silly diagram on Tuesday with the little web servers spinning around, and they're all communicating via some form of URLs passing HTTP style requests back and forth. And it's intended to be human readable. It is intended to be something that one can very quickly kind of break down what is happening here. Our most common method is the GET request, and it's as the English language implies, it is, I would like to get, I would like to access, give me some information, allow me to retrieve some information from the server. As part of that, you also specify the scheme, which for us, for web applications, is HTTP, or much more commonly, HTTPS. We then have the actual server, right? So we have our example.com, our kind of demo server for the web as a whole. We can optionally specify which port we want to access our web server on. There are default ports that I think we are now pretty familiar with, but there's no requirement you use those default ports. But they're kind of baked into modern web browsers. If you want to specify a separate port, you have to explicitly specify it. Then there is some sort of path or resource listed after that server and port combination, as well as one of many or all sorts of different kinds of sort of query strings appended to the end of that URL, that HTTP request here. Depending on the web application, that can be something very sort of straightforward and human readable. We can kind of squint at that and saying, we're doing some sort of request query of name equals Steve and age equals 44. But then there's all sorts of modern web stacks that take that kind of query string and use base64 to encode all sorts of complicated data. So you will find certain web applications where the server name's quick and there's maybe a port and there's a quick path, and then there's 100 kilobytes of query string associated with it that's attempting to encode some additional information. Then in addition to that, there's the header information that encodes in somewhat superfluous ways some of that same exact information, including information that is identifying who the user agent is, identifying what client piece of software is the one making this particular request. When that happens, there is then going to be some sort of response to that request. As part of it, a big aspect of it is the status request. If things are going correct, you'll get some response in the 200 range. There is a lot of specifications and sort of contractual language as to the different types of HTTP requests and status responses in general, with a couple weird exceptions. You're okay if you get something in the 200 range. 300 may be okay. It's part of kind of an additional handshaking mechanism. And then when you get something in the 400 or 500 range, something has gone wrong. In this case, we get response 200. Everything is okay. In addition to that, we get some server information. We saw that a few weeks ago for trying to fingerprint a server. The server will tell you what it is running within reason, and then the actual content would then follow from that request. In terms of our attack methodology for web applications or web servers, at the end of the day, it has to really be ultimately the same. And I already mentioned this a couple times now. This is, again, one of our takeaways, right? A web server is just a networked computer. So the same kind of methodology where we do some reconnaissance and scanning and enumeration is going to be part and parcel of our attack methodology for understanding any potential and taking advantage of any potential vulnerabilities. One slightly different aspect is, due to the nature of the goal of having a web application is to have some sort of publicly accessible resource. One way we can separately analyze the particular application is by creating a local copy, by mirroring that website. That is actually something that's gotten much more difficult to do with current web technologies than what it used to be. It used to be one could mirror a website by just providing those requests and just storing that information locally. These days, there are certain websites and very traditional utilities that one can still use to do that website mirroring. But oftentimes, to really be able to really explore the entire web application that is in use, you really have to kind of emulate a legitimate user on that website to be able to replicate, to be able to do that local copy of the web technology there. So there's all sorts of different tools and programming frameworks that basically do sort of that third option here, running a so-called headless browser, literally not even like viewing the result, but just emulating a legitimate user, even to the level of clicking around and waiting for a period of time and just trying to emulate what a legitimate user would be using to interface with the website. For certain web applications, that's actually quite necessary to actually be able to mirror what's happening on the website. For simpler things, we can use utilities like wget, webget, which even as a simple utility, if we were to run this on ece.iastate.edu, that's interesting. It was a different result than when I got this earlier. You can get your actual content back out here. That was not what I was expecting, because the intention was that was going to be returned as a different class. I'm extremely curious why that gave a different result than when I tried that previously. It could be I tried that at home and got a different result than what I got right now. But either way, it did work. So we do a wget request on that website, and it just returns the entire website information back. I didn't actually store that to a file. How do we store the results of that command to a file? Yeah, I don't know, pipe, file store, we just call it something. And then there's your request kind of stored in that file. We could actually open up that file and view it locally. It doesn't grab everything. One of those commands is saying just kind of grab that top level website and don't worry about recursively exploring all the potential links. But that is a little interesting. I'll have to explore later why I got a different result when I tried that exact same command this morning. So I'll have to explore that further. But there are well-established approaches to doing website mirroring, so you can locally analyze effectively the source code of that web application. And then there's more advanced approaches, because it can be more difficult if it was a truly interactive website for which the content isn't even provided until certain options are selected or navigation options are explored. Then you have to have some basically software solution that's attempting to exhaust those options to get a local mirror of that website. In terms of the different web servers that are out there, this is one of those statistics that there was a time people cared quite a bit about market share of both web clients, web browsers, and web servers. I'm sure there are still people who care about that. It's less of something that's sort of public knowledge or in the public consciousness. Perhaps because on the web browser side, there's very few options that are in use these days. And on the web server side, maybe it's the exact opposite. web serving has become something of a commodity piece of software in which there's enough open source frameworks that you yourself could build a web server in a week if you wanted to using these frameworks. So you have what have become kind of the well-known standalone web server softwares. That's your Nginx, that's your Apache, that's your Microsoft Internet Information Server and things like that. But then you have a lot of kind of just either cloud provider specific or even application framework specific web servers. And they are all web servers in the sense that they are listening to HTTP requests and they are returning responses back out. OpenResty is just a fork of Nginx. There's all the kind of magic that Cloudflare is doing for its own kind of caching and hosting of the internet writ large. And the end result, and this is June 2024, you can find more recent 2025 at least data here, is there is quite a bit of diversity of the different type of web servers that are in use. Diversity in terms of name, a lot of them are still based off of a lot of the same web frameworks. So Kestrel, for example, is if you're using Azure Cloud or ASP.NET, it's going to be based on Microsoft's frameworks. Whereas a bunch of these others are still really going to be based on Apache code base, so the original sort of open source web server that people still use pretty heavily. Beyond just our existing knowledge of vulnerabilities or CWEs, there are a couple things that are pretty much unique to web servers or web applications, maybe more heavily focused on web applications than strictly unique to web applications. One is this concept of denial of service as being seen as a legitimate means or legitimate end for an attack, which is if I have some sort of attack by which I can just sort of overwhelm the service itself and cause it to not be able to respond to other more legitimate attacks, well, I've accomplished some aim. And there could be other resources one may want to conduct a denial of service against, but it tends to be the case that it's sort of public-facing web infrastructure that more dedicated actors are interested in taking offline. And the very nature of having to be accessible to public access allows them to be kind of automatically susceptible to denial of service or distributed denial of service attacks. We'll talk a little bit more about that later in the semester. Specifically, we also talked about DNS and this kind of extra layer of going from a URL with a server name to what the actual IP address corresponding to it is. That is itself sort of a separate avenue for vulnerability that even if the entirety of the software running on the web server itself is up to date and reasonably patched in terms of vulnerabilities, if users can't legitimately get to it because something is wrong with DNS, that is also sort of a separate target for attacks on these. And one that is less prevalent as of a couple years ago, but is also making a comeback as people are writing applications and sort of forgetting hard-fought lessons of web servers in the past, is this category referred to as directory traversal attacks, in which you have legitimate URLs, you have things that are meant to be accessed, but users are allowed to try different things, and it's considered acceptable kind of light touch penetration testing to determine here's a legitimate URL, in which ways can I modify your legitimate URL to be able to access other things that you probably didn't intend to be able to access. There was a couple of very famous examples. The early 2000s was littered with, you wake up that morning, and yes, we had the internet back in 2001. You wake up that morning and you wonder which part of the World Wide Web is down today. And it was something. Something was always going down. Some worm was making its way across the internet. It was primarily a Microsoft problem, because if you were to look at market share of web browsers or web servers back then, it was primarily Microsoft software in that era. Two such examples was the Code Red worm and the Nimda worm. Again, one of those things that if we were to look at that today, we would say, well, I would never write a piece of software that has this CWE. The idea being that you have some sort of legitimate resources that you want users to be able to access. And again, we use this URL mechanism by which, in part, we specify not just the server, we specify that resource name, which is going to correspond to something generally in a file system. whether directly or indirectly, it's going to correspond to something, a local file on the web server itself. So the IIS had some very basic kind of directory traversal attack prevention, that if the goal was to do a GET request on scripts, and then a user attempted something like, well, let's attempt to just go up 2 directories, it was smart enough to detect that, but it wasn't able to detect all sorts of kind of obvious extensions of that approach, of which there's many other examples, but back in the early days, this was one such example in which, go back here, in which just the ASCII command for the / character would then be directly interpreted, and it wasn't smart enough to detect that that was an illegitimate request. And we can kind of squint at that request, and this is not the exact syntax that was used by the code Redworm, but it was effectively the same thing, which is you are requesting, it's legitimate to request something in the scripts directory, some JavaScript, some other script in your system, but instead we say go up a couple directories and go to system32 and actually run command.exe and execute something based on that command here. That is path traversal or improper limitation of a path name to a restricted directory. That is a vulnerability that I think in one era was considered a solved vulnerability. Now what we do have these days, and I've mentioned this briefly before, is the proliferation of kind of bespoke system as a service in which everything is kind of transitory, and to install this software, you're actually very briefly installing a separate standalone containerized or other type of system, and you're kind of running just arbitrary scripts based on that install instructions, and people are doing it and kind of forgetting some of the very basic vulnerabilities associated with providing user access to scripts on a server. Here's an example just using Perl here of how one could inadvertently encode such a thing. We have a legitimate directory we want a web application to be able to access. As part of that, there is an HTTP parameter that is specifying the user, just as part of the URL itself. And user equals Steve, like we saw before. And as part of the code, it concatenates that default path plus an extra directory symbol plus that username that's specified. We write this code, we assume the user is going to specify, or some piece of software is going to specify the username encoded in the URL. We get /users/cwe/profiles/Steve. We get whatever information is located there, without performing any other additional either sanitization or verification of what's provided in that user variable or username parameter, user parameter here. There's really nothing preventing sort of an arbitrary path from being constructed from that parameter. So what would wind up happening in practice is someone who's performing some pen testing or just attempting to mess with a system, instead of Alice or Bob or Steve, there's really nothing preventing the user from specifying, my username is upper directory, etc. password. And without any further access control mechanisms, or really just at this point, it has to be really blocked at this level of sanitization and verification of the input, there's really nothing preventing that file potentially from being kind of exposed as part of that either directory or improper path traversal here. That is something that's kind of unique specifically to web servers and web services, because again, sort of still the default paradigm of that computing is I do want users to have access, third-party public users to have access to my file system. That's sort of part and parcel of having a web server. I have these files, images, source code, things like that. I want you to have access to it, but I want it really to be boxed into this kind of pre-prepared set of directories for which I, as the administrator, have control over what files individual users should have access to. This allows you to kind of break out of that. It seems like an obvious thing to prevent. Have the web browser, a web server run as a user that only has access to this particular directory. Things that are kind of obvious today. It was a lesson, I think, well learned in the 2000s when, again, one would wake up in the morning and kind of wonder what part of the internet was down that day. But now we're sort of having to relearn as people are kind of quickly trying to get software out there and available and not really thinking about just some very obvious, user input sanitization approaches that are in place. Again, as I mentioned, there's a pretty significant overlap between what we think of as just software security in general and web application security, because a web application is just a piece of software. So everything we talk about today, I won't always bring up the corresponding CWE, but there is one. There is one for every single thing we're talking about today. So it is just a special class of software. It is just software at the end of the day. Again, why is this motivated as a separate topic that you should also be aware of separately from just software security in general? There's a few things. I tried to kind of enumerate the list of things that are different about web applications. Complexity is definitely one big picture. Modern web applications are extremely complicated. Of course, operating systems are extremely complicated. There's all sorts of user software that's extremely complicated. Web applications, modern web stacks are extremely complicated. That complexity leads to additional avenues or targets for vulnerability. So that it's just complex software is one reason we care about web applications. Connectivity, I already just kind of mentioned this, but not as explicitly so. The goal of a web application is to have people being able to access, to have effectively, for most web applications, sort of public access to your server. Whereas other applications, that's not the goal, and it's more straightforward to kind of limit the access to that software. Extensibility, this goes to the complexity of the web frameworks as well. Oftentimes, the goal is to have very quick iterations in terms of adding new content, adding new functionality. It's not intended to be a static thing. It's intended to be a thing that is dynamic, based on live data, and just constantly kind of changing by design. Another big one, and this is what this figure on the right is, and I said there's an XKCD for almost every example in this course, is like a lot of software, but certainly specifically for web applications, there's a lot of so-called antiquated paradigms, possibly for good reason. They were good paradigms. It is software built upon software built upon software, and you very quickly get to the 1970s when we start talking about where this software is fundamentally coming from at the end of the day. There's not a lot of truly new ideas in the software world there, and all of those web applications and frameworks, even kind of greenfield redesigns of frameworks, are dependent on a lot of things under the hood that no one person can have control over, no one organization can have control over. And you do wind up with legitimate situations exactly kind of like this. So here is all modern digital infrastructure, and I have an updated version of this picture I like a little bit more. And there's a lot of robustness. This is what this is trying to visualize. And as part of that modern digital infrastructure or web infrastructure, you have a project some random person in Nebraska has been thanklessly maintaining since 2003. There are legitimate examples. That's a joke example. There are actually quite a few very legitimate examples, and this is one of the articles of the internet is being protected by two guys named Steve. I don't know if anyone has heard about the Heartbleed bug, which was a very big deal at the time. A bug in the OpenSSL package, which was the basis of basically all encrypted web communications, and still effectively is today, that package of software. It was an open source project, and this is a bit melodramatic, this article, but basically maintained by people who just enjoyed the software and enjoyed maintaining that software package. They weren't being paid to do it. It was just a hobby at the end of the day. And it was a good piece of software. That's why people were using it. It turned out, and we'll maybe look at this a little bit later in the semester, it had a pretty obvious, only once you found it, a pretty obvious vulnerability in it, in which an if statement was being executed, but then the way the else statement was written, it was always executing the else block no matter what. Just, a CPRE 185 type of programming logic error in it that had been in there for years and years and years, that did lead to basic workarounds around encrypted communication. So that is just another aspect. That's a lot of all of open source software is that, but it's not just open source software. Proprietary software for organizations that have been around long enough is reliant upon, teams upon teams upon teams upon teams, and this one module that nobody really knows how to compile anymore because it was written so long ago. So there's closed source equivalents of this as well. And then the final point is sort of inadequate testing. only because it's a very difficult thing to do for modern web applications. It is not as straightforward as testing kind of standalone modules in which you just have a series of test frameworks and vectors that you're executing and guaranteeing certain results. It can just be more challenging to really exhaustively test a web application compared to a more typical piece of software. If you get bored in class, one example, this is a more interactive version of that XKCD, or you can just kind of, it kind of maps it to the P5 physics engine. And the idea is, again, everything is reliant on this, and things are good until we do this, and then I would argue the version of this in most commonly going down recently, well, there's two. Amazon Web Services is a very big one. Data centers in Virginia is a very big one. Cloudflare has also become this. It's not a thanklessly maintained piece of software. It is a multi-billion-dollar company. That has been the kind of universally relied upon third party that when they have a problem, the entire internet has a problem. If your favorite application is not working, that's usually a good reason why. So have fun with that if you get bored in class. I also found that XKCD is many years old. Here is what's considered the more recent version of that in the current era here. Don't know if we can see all of that. I think that's enough of it here. Just as attempt to kind of lighten things up a little bit here. So we are here. We are at the very top here. Here is our all modern digital infrastructure with, yes, the sometimes frankly exhausting, framework upon framework upon framework. Oh, what do you mean you're not writing your web application in WASM? It's incredible. Well, it is. It's just another thing to learn and to understand the security implications of. LeftPad is an example of software supply chain concern that we will talk about. Not that example, but we'll talk about what that means, why that's listed there. CrowdStrike, okay, that's fine. Security. There's Cloudflare, so that's a valid example. AWS here. Whatever Microsoft is doing, I guess, is an angry bird. AI kind of tilting the thing and about to tip it over. There's your two guys named Steve who are maintaining OpenSSL. DNS, we kind of mentioned that as sort of a separate, just fundamental vulnerability in the modern web. What else do we have here? Linux Foundation, I would agree with that. All underpinned by C developers writing dynamic arrays. I would also agree with that. It's slowly changing. Now it's mostly C++ developers using dynamic arrays. And then what else is our major concern here? I believe that's a shark biting an undersea cable. Also a concern. That's more physical infrastructure than web infrastructure here. I just like this one slightly more. I think that's pretty accurate in some ways. It's a pessimistic view of the modern web. It's another way to look at why we consider web application security and reliability as sort of a separate topic than just software in general. There is a lot going on with the modern web. I mentioned a couple of these. I would agree with that. When large parts of the web go down these days, these are the two most likely culprit. Occasionally it is a shark biting an undersea cable or some terrorism and other state-sponsored plots to disrupt undersea communications. There's a lot of fragility in modern web front-end frameworks as well, and so you see it on sort of both ends of things there. So as part of this, separate, but I think with a lot of commonality with the CVE maintainers, CVSS, CWEs, you have the OWASP, the Open Web Application Security Project. That is a nonprofit that really attempts to kind of keep their finger on the pulse of what is happening with modern web application security. Just like the CWEs and the top 10 CWEs get updated. Those are relevant and there's a lot of commonality there. The understanding is that what is important and critical for web applications is changing very rapidly on a year-to-year basis without any doubt. Their methodology is a little bit different, but it's based on surveys and kind of collating surveys of industry professionals and people who are actively either protecting or exploiting web vulnerabilities here. And it is kind of similar to the CWE because there is going to be a CWE for every one of these web application security concerns. It's a nice organization. They also provide some pretty nice software for basically vulnerability scanning of web applications. They also have a couple examples where it's your own kind of personal playground for they intentionally create a intentionally vulnerable web application framework and give you sort of training exercises to show various of these top 10 style of exploits. To the extent it's considered a standard on web application security, it's certainly something that if you're in this space and you're going to be a web dev or you're going to be involved with a security team that has web application responsibility, you certainly have to be fluent in these kind of concerns. And it does change rapidly. It's not something you learn today and you're done. These lists, unlike some of the CWEs, change pretty significantly every time they're published in terms of what's relevant and what's not relevant. Not always going in one direction, because again, what does sometimes happen is things that were considered solved are now considered unsolved, and vice versa, as different type of software gains in prevalence. So it is important. On the flip side, it's also a little boring. We'll do our best to kind of make it less boring. Awareness is probably a reasonable goal for you today. There's an OWA SP Top 10. It is related to common weaknesses in software because it is just software we're talking about at the end of the day. And specifically, it's very similar to the CWE Top 10. It is dedicated to web application security. But again, web applications are pieces of software. So you're going to see a lot of commonality there. Do you need to know which one is number 6 on this list versus number 3 on? No, I don't think that's important. But I think given that we did cover the CWE Top 10 and now we are covering this, you should have a basic high-level feel for what we're talking about here. We do a couple proof of concepts of these in the lab, including in this current week's lab. But this OWASP organization does provide a whole separate suite of tools to kind of play with these on your own and explore these on your own. We don't do it for the class, but certainly those who want to level up their own skills to know what it really means to have injection attacks, because that will be pretty high level when we talk about them and use them in the lab. What does that really mean in practice is something you only really learn by exploring further on your own. So without further ado, this is the OWASP Top 10. And it is a sorted list in terms of the priority of them, but I think anything that's in top 10 is something that is seen a significant amount in the field, and that's why it's collected into this list. And the first in the list is just broken access control. Now, we have understood as a security community access control for decades now, but we are still sort of tied to, I would say, antiquated paradigms of how one encodes access control and how one enforces access control. But what winds up then happening is that while for operating systems, it's a pretty well understood primary task of an operating system to enforce access control, web applications have gotten sufficiently complicated that the amount of fine-grained control they require is almost to the level of what an operating system requires. And a lot of those same kind of implementation challenges have to be re-implemented for any given web application or web framework for it. But otherwise, it's the same concept that you have a resource that legitimate users should be able to access and an illegitimate user should not be able to access. And how does one actually enforce that? It is never as simple as just saying, I have a bit, and that bit specifies whether you have access to it or not. That is necessary but not sufficient. What are the mechanisms by which one is enforcing that bit being 1 or 0 and limiting access based on that? This is the kind of thing it was in today's quiz as well, this principle of least privilege. Otherwise, it can be referred to as deny by default. One approach is nobody has access to nothing. I mean, that is one approach. But that is fundamentally in conflict with the kind of the goal of sort of, public-facing websites where my desire is I want everyone to be able to access my resources on my website. How do I kind of balance that trade-off of the most secure system is the one that's unplugged, I guess, right? How do I balance that with I want everyone to access everything? And that's a violation of that principle is part of the reason we still would have these concerns. And then just bypassing what existing access control checks are in place. There's all sorts of examples of broken access control that the OWASP provides examples of. This relates to database security, or can relate to database security, but they call that out as a separate thing. It also can relate to directory traversal, but that also gets called out as a separate concern here. This example is just showing a scenario in which there's unverified data in a SQL call that is accessing account information, and the application was not written clever enough to understand that the user has the ability to modify that parameter. And once a user has the ability to modify a parameter, which sometimes is a requirement that we would have, we have to have all sorts of additional validation upon those parameters, limitations upon those parameters. That is something that has to generally be written in a kind of a bespoke way on an application by application basis. Another scenario that would kind of fall into this bucket of broken access control is a website that really just doesn't have appropriate permissions on target URLs, that they are hidden via just not being publicly listed anywhere. This, in certain web frameworks, was a very common concern, that you would have an admin page, and the only thing really restricting the admin page was that by default, nobody would necessarily know what the URL was for that admin page. And there are still some web frameworks that say, well, step 1, install this package. Step 2, make sure you restrict access to the administrative console for this web framework. And of course, when you have 2 steps of an instruction, just like we have it in the lab, some will do step 1 and not do step 2, and that therein lies the flaw or the vulnerability here. The approaches to prevent broken access control is really just, could be kind of coupled into secure software development and administration principles more generally. Deny by default except for things that are explicitly intended to be public. One has to actually implement as well as test access control policies. Those are, it's a funny thing to think of, but those are kind of 2 separate things. Having an access control policy is necessary, but you have to have some enforcement of an access control policy. And I don't just mean in terms of like company, corporate policies that one has to follow. I mean literally in terms of the software that one is writing. Is another way to think about that is, it is one thing to have the bit, to say can access, can't access. You have to have separate mechanisms to actually enforce the correctness of that bit and to protect that bit as well. Some kind of well understood things that again are sort of being forgotten with modern web frameworks is, disable web server directory listing, which some frameworks do still do by default. Nowadays, what we really have to be careful about is various file metadata and backup files and secrets that can be encoded that are meant only for sort of local storage that somehow find their way into publicly accessible storage. And then another aspect here that is kind of interesting is, for certain types of API access, you may need to have some separate rate limiting or logging access control failures to kind of limit the ability for people to kind of exhaustively attempt these sort of things. Otherwise, you're relying entirely on good faith attempts by your adversaries, and that may not be the case. We'll cover one more today, and then we'll pick this up next week. Another one is just security misconfiguration. This can be a little tricky because when you have your web application, there's going to be at least 3 different layers where this misconfiguration can happen. Again, a web application is just a piece of software. So misconfiguration in the actual software, your JavaScript, what have you, itself, that is an issue. Then there's the actual web server process itself. Did I install Apache correctly? That is not necessarily secure by default. One has to actively be knowledgeable about how to manage such an installation in a dynamic way. And then on top of that is whatever your resulting system or systems are. That could be your cloud hosting provider. That could just be your bare metal server where your web server processes are running. So it becomes just a more complicated task than just saying secure versus insecure configuration of my software. There's multiple layers to it, and the interaction between those layers is not always that obvious because the users, the policies, and the enforcement of those policies, they don't always align up because the permissions one may have, the authority one may have to implement various policies may not always be perfectly aligned depending on ownership and depending on what features are actually expected or necessary. But even this can be sort of just straightforward, maybe seemingly obvious things like avoiding default accounts or avoiding default passwords, having features enabled that you don't actually need but are just sort of included by default, or things like having error messages when a user types in a wrong account or a wrong password. If your error message says wrong password, well, then the user knows at least this account was a legitimate account. Things like configurations of that nature. And there's almost as many example scenarios as there are web applications here. Scenario one is you're basically working with a default install. And that default install includes all sorts of administrative or sort of maintenance features that you should not have be publicly available. If you're not aware of that, if it doesn't come with flashing red text saying, please uninstall this particular service, you may have all sorts of things that wind up being publicly exposed. This is related to directory listing, but just kind of default directory listing allows maybe access to the source code for your web application. And from that, they can find additional other kind of vulnerabilities from there. And then as I mentioned that, where these permissions would have to be enforced can really depend on how one is implementing and hosting the web application in the first place. We move from one cloud service provider to another cloud service provider, and all of our appropriate access control and permissions and monitoring, which was perfectly appropriate on server one, provider one, now, unbeknownst to us, there's a slightly different set of assumed defaults on cloud hosting provider two, and you did not change a single line of code in your application, but all of a sudden you have a vulnerability that didn't exist previously, only because of something that's kind of underlying your web application having changed, and a certain assumption has been broken by that. Let's leave things here for today, and we'll get through the rest of these, and we'll try to break it up as we go on Tuesday. Again, for now, I think our goal is just awareness of these things, where to spot them, and an appreciation of the complexity of the challenge of providing secure web applications. Okay, enjoy your rest of your week and your weekend.